All right. Welcome back. Yeah, so I'm in the game editor code here a little bit. Now we've been talking about implementing a map for the scenes, so that you can get a nice overview of all your scenes and how they are connected. And I was thinking about how to automatically generate it from the things. So if I open up a thing here, let me show you here. Right, so the idea is that you would have a bunch of scenes. So let's just make a thing here. So let's say this is a scene here, and it has a bunch of connection points. So let's create that. So let's say we have one over here, and one over here, and one over here. Oops. Okay. Now let's actually make this another color. Well, maybe yellow was bad. Maybe red. Okay, so the thing is that I've actually classified two different types of exits here, or connection points. So this is actually a vertical, and the editor already knows that. However, it won't know that for long, I guess, unless I keep that information. Yeah, it's probably gonna lose connection a little bit once the exits are totally generic entities. But for now, what we could do is we could we already know that this is horizontal and this is vertical. So maybe what we could do is have another, if we have two scenes like this, and we know that these two are connected, then we kind of know the layout a little bit. So let's say we put this in a grid. So you would have a grid like this, maybe something like this. Yeah, something like that. And so when let's say we have a thing over here, and we flip that like this, so we have a connection like this. Okay, so we know that this is vertical, and we kind of know which direction as well, because if you take the center point of the scene, and then you can take if it's above or below the center point. If it's above and it's a vertical, that means the connection goes up. If it's below, that means the connection goes down. However, this won't really work too well, I realize, if you have two connection points like this, and they go, let's say they go to different places. So now all of a sudden you have maybe two scenes in one grid, which won't really work. I mean, yeah, it would defining it this rigidly would lead to a lot of edge cases and stuff, I think. It would be nice if it worked like this, but it works as long as you only have one exit on each north, south, west, east. But as soon as you have two exits on the same sort of orientation, then this becomes yeah, very complicated very fast. So I mean, technically you could also order them in left to right, and then you order these left to right as well. But then it's okay, but let's say this guy has this one has, oh, let's say this has one like that, and then this leads to, I don't know, another point here. You lead there, you lead there. So let's say you have this thing. How would you put this? Where do you put this now? So it's like, yeah, it's very messy. So well, actually, one thing that we maybe could do is we could build the tile. We could take all the tile maps, and like stitch them together, maybe all the scenes, and stitch them together like this. So instead of doing this, we do, let's say we have a scene here, and a connection point there. So let's say we have this scene, and then we have another scene which connects to that, and oops, oh, let's hide this. Okay, then we put them like this. So we stitch them like that, because then you can make like a map that is like, you take the how would you do that? So you take the like the exit of one and merge it with the entrance of the other, or yeah, something like that. So you might be able to end up with a map like this, and then you can sort of see also like the logical connection between everything, like, or not logical connection, but if it makes sense how the tile maps are like laid out and how they are, what the size of them and stuff. But that doesn't really matter, I guess, that much. But it would be nice to have a map that that you can like just jump to different scenes. So yeah. I'm just not sure exactly how it would work. I mean, this could work, but it would be a bit funky because the exits are like not exactly on the border, and it's gonna look maybe a little bit weird, but at least it would be something. It would be like a temporary tool that we could use to easily access, or maybe we even keep exits and entrances as special entities. Like, why not, you know? It makes sense to have it like that. If we do it this way, we don't need to worry about any grid or any like worrying about where, like, which direction the entrance and exits are. We just need to have one scene as a starting point, and then we basically go through, like, iterate through all of the connections of that scene, and we map them out onto a sort of, we can map them out to a texture, and you could even like draw the tile maps themselves onto the map so that you can see the whole thing. Yeah, so that it's an idea. I don't think I'm gonna maybe do it right now though. It feels like such a it feels like a thing that is, oh, it would be nice to have, sure, but how much, like, would you really gain from it? I mean, it's nice to get an overview and look at it, and nice to be able to like jump around, but it's like, it's gonna take, I think it's gonna take some, I mean, it might not take that long to actually implement. That's the whole thing. Like it's meant to be sort of a throwaway thing that we just implement very quickly, and we can like use it. And it's not supposed to be perfect. Yeah, maybe we can just do it. Actually, okay, so all right. All right. So we're gonna need a render texture. Render texture 2D. Is it the same thing? Yeah. Okay. And oops. Render text 2D. Let's see. Set it to undefined. We'll have a load function. We have a deinitialize function. Okay, load. I mean, why even bother? I think what we do is we just have an init function. I think. Yeah. And we return a seed map. Now this render texture, I'm not sure what the size would be actually. It probably would be something that would like change the size depending on how many scenes and stuff we have. Yeah, so it's like whenever we wanna like regenerate the scene map, we go through all scenes and basically we could like calculate the size first, then initialize the texture with that size, and you know, yeah. So I think we could do that. We could actually, if we get, let's say we get the context or the, what do we need? Like the index? We actually need to like load all the scenes in order to do this almost. We don't really need to load all the scenes. We just need some of the information. Like we only need like the width and height of the scene. Maybe it makes sense if we would put, I mean the scene files aren't that big, so it's not that huge big of a deal. Well, anyway, not right now anyway. But we would need to like, okay, maybe it would make sense to have like a header file in that case. Like if it becomes a problem, you could have a header file for the scene which defines the tile map, and then you can use that to get the tile map, and then that tile map would have a header that would say just, you know, the width and height, let's say. So yeah, that would be something that could be done. Because now it's like, yeah, we have to like load basically the entire file, and I'm not sure exactly how how the standard library does it with JSON, if it's able to like skip parts, like let's say width and height is the problem is this. If we open up a time, I'm not gonna open up a time map JSON, but they basically look like this. You have well, I guess maybe a name, I'm not sure, I don't remember exactly, but you have a bunch of different properties up here. Maybe name, you have ID and name and stuff, but then you also have yeah, width and height. No, but then you have like tiles or layers, which is a list of, so this thing is like, this thing is the largest thing, is like very a lot of data. So this is where the main data is, but you only need to really read these things, like the top part. And I'm not sure if the standard JSON library, because what you can do is you can have a struct, which is, let's call it time map header struct. And let's say we only include the things that we need. So we need ID, the name maybe, and width. I'm just winging the data types in here, it doesn't really matter. So if we exclude layers, and let's say it only has these, and then you use JSON to, yeah, I want to read this file or this type from the data. I'm not sure if it actually only reads these and then it skips the rest because they're not in the file. But the main thing is that we don't really need to read in the entire file. Once we've populated all of our properties, we can basically we don't care about the rest of this file here. We only need to read this. And I'm not sure if it right now if this is an actual problem or not, but it would be nice if we could just read the header without having to read in the whole file. Because here we actually need to read all of the files, all of the headers while we're building the map. I mean, it could be like a process that sort of happens once. However, it would have to be updated every time something changes, and every time you like reload the editor and stuff, like, or restart the editor. All right. Yeah, I mean, we could just try and implement it and see how long it takes, and whenever it becomes a problem, we can deal with it later. So so let's just do it with initial. I mean, actually, let's do this. Let's do this. So let's do load render texture, and width and height is like 1. Okay. So we'll do that. So we have something there. Deinit will do that, and then we have rebuild. Okay. Now we need a context here. And so what are we doing here? Well, one, we need to start at an entry point, which is a scene. For each exit in the scene, we will do, so for each exit we want to do, well, we will basically want to start a recursive thing here. So we're branching out. For each exit we want to call sort of a function that sort of adds these things to a list, actually. So I think that's probably how we want to do it. So what you would do is we create a list here of well, let me explain here first. So add so load exit target scene. Okay, and then we add target scene to list of scenes processed. Okay, because then we can keep track of that. And actually there's a step before this. So we also, this is actually B and C here. Before we load or do anything, check if scene is already processed, because you might have several exits leading to the same scene in from different places. So you could, when you do a recursive search like this, like a in a tree structure, but it's not really a tree, it's more like a graph structure, a network. So you could potentially end up in a circular loop. You could end up by things, you know, going back and forth even between, you know, because two scenes have could have, each one could have an exit to the other scene, and then you end up in a loop, infinite loop. So because you start at one scene, you check the exit of that leads to the other scene, and then you check the exit of that, which goes back to the original scene, and then you go back and forth. So you have to have a list of which scenes you've already visited, or processed, as I call it here, and then you will add. You don't process them again if you've already visited them. So we will check if the scene is already processed. So if scene is already processed, continue. So we'll skip that scene. So skip. But if we don't, then we continue here. So we load the scene, we add this scene to the list, and then we also call. So here is the recursive part. Here we call this scene process function. I'm not sure what to call it. Process scene function for target scene, and that will be the recursive point in this. So that will call for each exit in the scene. You will call the process thing again, So this would basically be, well, rebuild won't really, rebuild is sort of the starting point of this whole thing, but then we need like a function that we call again and again recursively. So this will be not public, this will be sort of like a process scene, and we probably need a context, but what we need is we need a list of scene processed. Let's make it an array list of something, UUIDs maybe. So we need, what did we need? Standard. Okay. Whoops. Oh my god. Man, I always do this. Okay. So you didn't see anything of that. Let me just go through this a little bit. Right, so we have the scene map. And we have a render texture. The idea is that we will load in all the scenes and all the time maps that are sort of connected to each other. I'm not sure what to do with loose ends, like if you have a scene that's not really connected to anything else. I think we'll skip those. We'll take the ones that are, maybe this will be only if you enter one scene, you will get the map that is like of that scene and the things that are connected to that scene. So maybe this would actually be in, because the thing is with this scene map, this scene map is gonna be sort of not part of one editor. It's gonna be more like a global thing, I'm thinking, because it would be nice if you could just access the map from anywhere. Like you just press M or something and then the map shows up and then you can go to whatever scene you want, instead of having to open up a scene first and then get the map from there. But the issue is if you have a bunch of disconnected scenes, like how would they show up? I guess, yeah, that's gonna be a problem. But I think what we'll do is we'll just do very naively. So we'll just start at a scene that is like the first, yeah. Okay, so never mind that. I'll go through that later, but let me just explain what I did here. So we have the scene map. The render texture is where the scene will sort of be rendered, or this map will be rendered so that we can see it. We have the init function where we just initialize a 1x1 render texture. So actually, does this have an this could be an error. So actually, let's do a try here. Okay. And then we have the initialize. Yeah, we unload the, I mean, what we could do, we could make it nullable as well, but, and then initialize it to null at first. I guess we could also do that. Let's do that, because then we don't have to deal with any of this. So we'll just set this to null instead, and then we don't have to do anything there. Okay, yeah, when you have the initialize, we just unload the texture. But now we have to check if it exists first. So let's do that. All right. We have rebuild. So the idea is that you would call rebuild whenever you need to like update the map. So we call it at the program start, or when you open a project. And then we can also call it when somebody updates a tile map, or when somebody updates a scene. We will call rebuild. Okay. Or when somebody saves a scene or a tile map, we can rebuild this. So yeah, and the rebuild is basically we build the entire map from everything. So the idea is we load all the scenes and all the tile maps, or we start at one entry point. So we check if, I guess we could iterate through each scene and see if it has any connections. And we, as soon as we find a scene that has any connections, we will use that as a starting point. So yeah, first will be find starting point. And then we call process scene for starting point, or with starting point. Okay, and this is the process scene. So this is actually a process scene. So let's move this over here. Right, this is process scene. Okay. So basically this would be it for a rebuild here, I think. Yeah, we have to initialize, we have to initialize the list of processed scenes. We probably want to store that here as well as a list of UUIDs. Because then we can, yeah, we can optimize later by storing it, but I'm not gonna worry about that for now. So we start at some scene that has connections, find starting point scene with connections. First scene with connections. We call the processing with starting point, which will then start a recursive process for all the scenes that is connected to this scene. So here we check if the scene is already processed, we skip the scene. Actually, this should probably happen. Now, it's better if it happens here, because then we don't need to load it and stuff. Yeah. So for each exit, we check if it's already processed, we skip it. We load the exit target scene. So we make sure that we have the data. Actually, we should also load starting point. See? Yeah. So that's the initial thing, and then we load. So here we load the target scene here. Actually, we could just load here, I guess. Load scene, and then for each exit. So then we can actually, I think we can just have this here. If the scenes are already processed, because this is usually how I would like design a recursive algorithm like this. You have in the recursive like function, the first thing that happens is that you check if you really need, you check for the termination condition, which in this case is if it's already processed, we skip it. So that's the termination condition here. Then we can process it. So then we load it. We add it to the list of scenes processed. Then we go through each exit and we recursively call the process scene function for target scene. Yeah, that makes sense. Yeah. So and then once we have all of that, we continue down here. So then we get a list of scenes that we need to process, basically, or that we have processed. Well, we haven't really processed them. So what we also need to do is we need to get the, well, we have the exits of the scene. We have all the entities, so we need the exits of the scene. We need the entrances of the scene. We need to match exits with entrances. Yeah. So we could build up a more intricate version here. We could have an ID array hash map actually. Yeah. Let's have an array ID array hash map. Let's make it a pointer just in case there's some weird stuff going on. And well, I mean, it probably should have to be if we want to modify it. Okay. So let's just make it here. Let's make scenes processed. Now, what data would we want to have for this? We probably want to do a special kind of thing because we need to. What do we need to actually build a thing? We need to connect the exits with the entrances, right? So each scene, like while we're processing that, while we're walking this tree, we could build a thing. We could build it there as well. And we probably want to keep some information about where the time maps are, because if we only have a render texture, how would you go to the different places? The idea is that you would know the sort of area, or yeah, you would know like the rectangle of each time map. And so in theory we could have, like, if you hover with the mouse, it's like it could even show like a border around the scene that you're hovering, and then if you click it you go to that scene. Yeah. So we need to keep track of the size and position of each time map as well, as they are sort of generated here. So let's start there. Let's make a struct here, which is gonna be map cell, I'm gonna call it. Scene ID. And yeah, because that's used to know which scene we want to go to. Then we have the size and the position. Now this should actually be maybe not, yeah, this should be like floating point vectors. Hello Pelair7, have a nice day you too, thank you. Alright, so map cell, yeah, so this would be map cells, and let's do empty. Alright. And basically let's do this. So starting point, starting scene, find starting scene. We need a context. Oh, this needs to be, I thought I could switch these around. Swap. I'll do it. Okay, find starting scene. So I'm gonna do that. Well, it's not, I guess it doesn't need to be so. And this would now be a UID, I think we wanna get. So that's the starting scene. We also need cell. Starting cell. It's going to be load cell and then starting scene. So we need a load cell function. With a scene ID, which is gonna return a map cell. Oops. And then this cell, yeah, it's just gonna get populated. The thing is, at this point, we don't really know the position. How would we know the position? Well, we can start at 0, 0, I guess. But then, when you load the next cell, let's say, then how would you know, like, the center point of that? Well, how would you know the position of the next cell? Well, what you do is you need the exit of the previous cell to get the entrance key, and then you match the entrance, so you find the matching entrance to that exit. And then the exit, so the exit of the previous cell will become an offset you would have the position of the next cell such that the entrance of the next cell matching the exit of the previous cell or have the same position. That's how I think it should work. So then, because then the entrance and exit, it's at the same position, that's only like one possibility of that, so that should work out. So what we need for loading a cell is not only which scene, we also need the previous scene, or we need like an entrance key, basically. We need an entrance key, and we need the position, the relative position. Well, let's see. How would this be? We need the relative position of the exit in relation to the origin of the whole render texture. Yeah. So we need the entrance key, and we need exit position. Okay. Right, it might we might change things around here, but I'm just trying to figure out what we need, so we don't like build on tiny thing and we rebuild it, and then we have to rebuild it just because, oh yeah, we need this as well, and then we have to like restructure the whole thing. So right, so that's what we need there. Now here for this part, actually entrance key is sort of like, it's nullable basically. These two are basically nullable, I guess. Well, let's make that loads. Let's just make this like load cell options. Entrance key. So actually let's make this a tag union here. Why not? So this would be a starting cell, and this, and then a relative cell, which is gonna be weight-wise. It's gonna be like this, and then this is gonna be a struct with entrance key and exit position. Okay, and then we can put that as options. Or I guess it could be like cell type, or I don't know, whatever. No, it's load options because relative to something, yeah. Okay, but anyway, so here, yeah, so now we have that. So we can do a switch on options, and if it's the starting cell, then we know that we just load the thing and we put it at 0, 0. Basically, the position, yeah, it doesn't really matter. Yeah. And the idea is that once we have all of the cells, we have all information we need to just go into the actually we could use the time map ID here as well. So now we should have all information we need to loop through all of the map cells and just render them from this information. That's my goal here. So once we've built this map from of these cells, we can just, because it's a array hash map, so we can just loop through it as an array and just paint this one by one. Now the order does matter, but hopefully there's like not gonna be any overlap or something like that, but we'll see. It's just gonna be a crude tool anyway, so it doesn't really matter that much. Yeah, so actually, you know what, I just realized that, okay, if this is actually going to be a problem with finding the start scene automatically, what you could do is you could just have a drop down, as we have for selecting an entity reference. For the scenes, you can have a combo list of all the scenes. That should be pretty easy to do. I mean, we have a convenience function for that as well. So yeah, that shouldn't be, because then you can just choose, okay, which scene is going to be the starting scene, and then it's going to build a map from that starting point. So that could be a good sort of manual solution, I guess, to that problem. Okay, so what now? Yeah, just eating some breakfast there. Okay. Yeah, do we want to keep this information? I don't think so, because we need to rebuild the entire thing anyway. So it's just gonna be something that we throw away. But we do want to defer, deinitialize. Wait, why is? What's happening? Okay, but I'm pretty sure we need the allocator. It's probably because something down here, maybe. Okay, yeah. So is that why? Okay, I'll just do this. And does this work now? Okay, there we go. Yeah. Unused. Yeah, it's gonna be used. Definitely, because we're gonna render onto the render texture. And so at this point, we should have all the map cells. So then we render, call render map with list of map cells, right? So we should have this like render map, and we need itself, so we need scene map, and then we need scenes processed, or I guess we could call it map cells. Map cell scenes processed is gonna be, let's call this map cells. Yeah. Okay, and once that's done, we need to build a UI for it as well. Actually, you know what? I'm stupid. We need to store this, because then how would we know where the boundaries are for the time map? So we really need this. And also we need the scene to be able to know which scene we're gonna go to. So yeah, we actually need it. So let's just call this map cells, and this would be an ID rehash map to. So actually, we don't really need the scene ID. We could just, I mean, we have the key here, so this would be the scene ID here. There we go, and then that's gonna be empty. All right. So we don't need to do this. No, we need to do that. We do need to do this though. Self map cells. It's weird how sometimes the OSP just stops working when it feels like it shouldn't. Okay, I'll stop complaining about the OSP. It works pretty good now. Okay, there we go. That's what you get from using a language that is not really, well, it's starting to become more mature. But anyway, so starting cell, yeah. So what more do we need to do? So we have all that. I'm just thinking higher scope here, because to get this entire feature in, so we can use the map cells then to build the UI to actually just and the render texture. So then we render this texture. You can add camera controls to it as well, so they can move around. This would be probably in its own window, where you just press M or something to open the map, and the map will show you, or have an option up in the project thing, and you would open the map, and then you would it would open a window. You see the entire map. It will probably build it if it's not built yet, and then, or we build it when we open a project. Yeah, that's better, I think. Maybe it depends on how much time it takes, I guess. And then yeah, then you can use that. So yeah, with that should be it. Now we just need to implement all this. So let's go. Yeah, so let's continue here. So let's say we have a starting scene. We need to load the cell. We need the context, the scene ID. We need the options. So this is going to be the starting cell. Okay. Let's start with the finding scene here. So find the starting scene. Now this would actually require us to actually load the scenes. So first off, we need to grab all the scene IDs. And this is going to be get IDs by document type. Okay. Right, so here that's the scenes. Then we defer free that. Okay. Now we loop through these. Oops. We should have all the scenes there now. Okay. So now what do? well, we need to request the document. We need to go through the entities and see if we have any exits. So we need the scene document. This document type. ID. And this could be an error, I think, yeah. So I guess if there's an error, we just skip it. So actually, this could be a nullable, I guess. Or should we do? Let's actually make this like it can throw an error. So let's do try. Oops. Okay, try. So now we get a nullable pointer. So let's do or else. I guess we just continue if we can't find it. Okay, so now we should have a scene document here. Even if we can't get the type. But the scene document and yeah, so now we need to go through. Let's actually go to scene, like document scenes here. Let's check if get entity by. So what I want to check if we have a convenience function for getting an entity type or anything like that. Like, do you have, like here we have get entities, but draw entity, get ID. No, so we have to use like scene document get entities. So we need to loop through that. Actually, this would be get entities items or something like that. Because I believe this is, yeah, you get an array list, and then this is an entity pointer, and then I think it's like entity type. Yeah, we have to check the entity type, which is this thing. Yeah, so we will check if entity type is equal to exit, then we return the ID. I guess we could have an error that is like no scenes found or anything like that. So something like that. Yeah, just to give a little bit of context to what's happening. Scene map error. No scenes. No valid scenes found. I mean, I guess if we find a scene that it doesn't have connections, but we do have scenes, then we should just pick one of those. But I mean, then you don't really need a map anyway. So, but okay, no valid scenes found. Okay. So we'll return just to have this working here. Scene error. No valid scenes. There we go. So there we go. So if we go through all the scenes, if we find a scene that has the entity that has exits, we will use that as a starting point. If we don't find anything that has exits, we return this error here. Alright, so that's the starting scene. Load cell is the next thing that we're doing. And yeah, if we have a starting cell, then what would we do here? Let's return this. So what we have is we have a timeUp ID. So actually we need to load in this scene. We need to load the scene document. And this is also errorable. If we can't find the thing, this should also be like a load cell error. Like missing document or something, I don't know. It should probably not happen here, but let's just have it. Missing document. Okay. So now we should have that. Now the timeUp ID is going to be. Is there a convenience function for that? Get timeUp ID, yeah. So get timeUp ID, which should exist, but because we always have a timeUp, right? So we always have a timeUp, but this could also be nullable. Right, because the timeUp might not be set, which is the case when you first create a scene. The timeUp isn't actually set. So actually, this could technically be null in that case. So we have to do this. Okay. Where are we here? Right, so that should work. Next up is position. Now, if it's a starting cell, I'm just gonna set position to 0. And size, we should have the size. Well, actually, we need to request the timeUp ID for that. The timeUp document. Well, let's do timeUp ID is scene document get timeUp ID, and then we have timeUp document. So we need to load the document as well. timeUp ID. If it exists, it's basically, yeah. Or else return scene mapper missing document. If it doesn't exist, then there's a weird error, so we'll do this. Let's see, timeUp ID. But the timeUp ID might be undefined, so it's like if timeUp ID is undefined, or if it is defined, I mean, we will get. This is actually scene ID. Let's use this shorthand here. Otherwise, if the ID is null, then this is also null. So this is like a time document or null. Whoops. Oh no, did it crash now? Oh man. So I was actually trying to check the type of this, and I knew that the type would not be able to be resolved, but I didn't think it would crash the program. Wait. Oh shit. Okay. What was it? Scene map. Yeah. So let's try and recover. Load cell. Yeah, we're down here. Okay, so we missed a little bit. It's no big deal. So we had time map ID, scene document, yeah, time map ID. Now let's not do that again here. But time map document. We have time map ID, we have an ID, and then we can do try this request document type, time map, by ID there. Also this ID is, same ID. And if we don't find it, then we return a CMap error missing document. Otherwise, we set this to null. Okay, now I'm not gonna check the type here. It's a bit concerning that we have like a ticking bomb here, maybe. Like, I don't dare to do that right now, but let's hope we don't crash. I'll save the file. Do we crash if we try to do this? Type of null, okay. I guess what we could do is we could just not have an or else here and just have it null, I guess. Because it's inherently nullable, and then this would also be nullable, so why is the type of null? I guess it's just null then, like the type. It can only be, it's like its own type, the null type, but it's also like a document thing. Okay, but anyway, so we have the position. Now we need the size. The size would be, well, we don't know. We have to go to here. Yeah. So basically, we take the grid size and multiply it by the tile size. Yeah. Grid size times the tile size. We should maybe have a convenience function for that. Grid size times the tile size. That's the size. However, these functions return a vector, I believe, like a integer vector. Yeah. Excuse me. Yeah, these are integer vectors, so we need to convert them by using float from int. But it's easy enough there. Okay. Let's see. All right, so now we should have also the starting cell. We need to do a try there and a try there. Now we have the starting point. We have loaded the cell. Now we need to process this scene. We also need to add it to the processed list. Well, no, that's gonna happen in the process thing. Actually, this will happen in the process thing. Ah, that's gonna be an issue. The way we set it up is loading the cell in the process function, in the recursive function here, which we do over here. But then how would we know if it's the starting scene or not? Do we need, and we also need like context here. We do need like the previous cell. Let's actually do that. Let's do previous cell. And this would be a map cell. However, it's nullable. So if you don't have a previous cell, then that means it's the starting point. If previous if null is passed as previous cell, this is processed as the starting cell. Okay, so which means that we don't load the cell up here, we do it down there. But what we do want to do is we just want to start the process here. So we're just gonna do self process scene, and we don't need to pass this because we already have it in self. And then the previous cell is gonna be null. Okay, and then down here we wanna load the cell here. Well, we wanna do it soon. Anyway, I'm just copying it down there. We need self is gonna be cmap, so we don't need map cells. We do need the context as well. So context, no. All right, and then render map. We don't need to pass that in either. There we go. And then we're done basically here. Okay, so this function is, I guess, basically done. This is done. Load cell is not exactly done yet, but we'll get there. Okay, so now it's the process scene. So first we check if this current cell is, oh yeah, we also need the ID for the scene here. So scene to be processed. Okay, which will be the starting scene at first. So what we do is we say if we have our map cells, map has, or what's it called? Key? Get key. Wait, exists? No? What is it called? I'm pretty sure there should be one function that checks if something is just exists or not. Get maybe not. Contains, that's right. If this is contained, then we can just return. So that's the first part. Then we load the scene, but so load cell options is that, and this is depending on previous cell. So if we have previous cell, then we do something. Okay, then we do relative cell. stuff. Otherwise, we will do starting. Actually, okay, the relative cell has entrance key and exit position. So we actually need to find the exit position of the previous cell. So actually, maybe we should just put load cell options in here in that case. Yeah, let's just load cell options, and this would be load cell options. Okay, so we don't need to build a thing here, we can just pass it in here. Load cell options, whoops. No. Okay. It's also nice to build these things because you learn like this recursive process and stuff. I mean, it works the same as in other languages, but it's like doing it in a SIG way, like thinking about how do I pass parameters, like I can build up a struct that I can pass in and stuff like that, and just the error handling, the optional handling and stuff like that. So it's like it's I mean, it's same as other languages, but then it's also like different. So yeah, it's nice to build stuff like this to like learn SIG as well. So or yeah, so starting scene. No, this is seen to be processed. Yes. Okay. So now what? We have loaded the scene. We are checking if it's gonna be skipped. We need to add it. Put key value is the cell. Alright, so now we have that. I guess we can do a try there. And then, so we have this now. Now we need to go through each exit and call processing again. So let's just loop through. Well, what we need to do is we need to grab the scene document, and it should exist, I think, because otherwise this would be this would not work here. So we should, this should be like, but let's just add the same kind of thing here. Okay, so that's this. So that's scene document. Now we need to, yeah, we need to go through scene document, get entities, entity. Why is that not? Oh yeah, it's out on items. Okay, and then if entity is equal to exit, let's actually do a switch, or no, let's just do this. If it's an exit, the only thing we're well, we are interested in the contents as well. We can access it anyway, but we do wanna, what we wanna do is we wanna add, or yeah, now we wanna recursively call this. So now if we reach an exit, we wanna process the scene again. This will be a try on self. Context. Now the scene. This is gonna be entity type exit. What's it called? Scene. Scene ID here. Oh, oh yeah, it can be null as well. Ooh, okay. So I guess if it's null, we don't really wanna do it. So let's grab the scene ID here. And let's call it exit scene ID. If it doesn't exist, then we just continue. Don't care about this. Alright. So that wasn't as bloody as I thought it would be. Or as it felt first there. Processing, let's see, seems to be processed. Load cell, yeah. So now it's the load cell options here. Now this is a relative cell. And why did I get like the first one, but then it's like, no, now I give up. I don't know what you want. So we need an entrance key and an exit position. And our entrance key is actually in entity type exit entrance. Key, and that one is, oh, it's that thing, right? So we need .slice, I believe. Yes. So now we get that. Let's have it the same type so we don't get any weird memory errors or something. Alright, and then we also need, what was it? Exit position. Now this should be, let's check where this is. Alright, that's on the entity itself, so that's just position. Except we're gonna make it into a float. Vector. There we go. Alright, so that should be done. Oh, yeah, there's one more thing. This is like relative to the scene position of this particular scene. It needs to be relative to the whole map position. So how would we do that? So let's think about this. So we start at the starting point, which is 0, 0. Now the exits to that one would be 0, 0 plus the exit position. So that's just the exit position. Now the next one would be the exit position. Yeah, so I'll draw it here. So let's say we start here. Oops. So here's the start. I think it's either there or in the middle or something. But let's say the origin is here of the map. Then the exit is over here. So that's the position of the exit. But then the next cell will be over here. And so now the exit would still be the same offset, but let's say this guy also have an exit over here. So now this scene's position is like over here, but we need to calculate sort of the offset towards the center of the map. So we're matching this entrance. So we're taking this entrance position, which is gonna be that vector here. That's the entrance position. This is the exit position. And what we want to do with this one is get this position. So how do we go get there? So we'll take this vector and go up here and then here. But then we get back to 0. But there, and then there's this vector like this. Yeah. So how do you get that like how do you get this vector? You take, but you have to be here. Okay, I'm confusing myself a little bit here. Because this is where we are. This is now we're loading the next cell. We know this vector now. So we could take. No, I'm confusing myself. I can't think straight here. Man, maybe I need another example. Like, let's say over here. Okay. So we start here. This is the origin of the map. We have a vector over here. Okay, that is the exit in relation to this scene. Then we load the next scene, which has this as position. So we need to figure out this position, but also, yeah, so the next exit position will be, yeah, so we need this position as well. So what would that be? This is the vector to the entrance. So wouldn't it just be this minus this one, so, or subtracted this one, which will be the equivalent of doing this, right? So then you would end up over here, right? I think so. So you take the exit position of the previous cell, you subtract the entrance position that is connected to the exit, then you get the tile map position. Yeah, I think so. Okay. So now let's see, when we load this cell, yeah, this is the problem here. So we have the relative cell. Now we need to get that. And this would be the same thing, I think. Yeah. Now the position. Now this is going to be the relative cell exit position minus, let's see, let's go through this again. So let's say we start here. This is the exit position minus the entrance position of the next one, of the matching one. Okay, next time though, let's say we have another exit over here and another cell over here somewhere. Now we have this thing, we have a vector to that, and we also have a vector. No, actually this will be this vector here, I think. So how do we get this position? Well, we take this vector minus this. So that would work. Yeah, that seems to work. Okay, as long as we keep the origin, the positions of the exits here. Okay. So when we calculate the exit position of the relative cell, that has to be to the origin, because otherwise the positions won't really, they will all be like relative. They need to be absolute they need to be relative to the map and not relative to their respective scene. Okay, but then how do we get the entrance? We need to get the entrance position. So get entrance position of this scene document with the entrance. What is the key then? That is the relative cell entrance key. Okay, so we need that function. Get entrance position, so we get the scene document. We get the entrance key. What's that? Yeah, that's zero terminator. And this would be this type. Floating point vector. Okay. Now, well, we basically go through each. I'm just gonna check if there's a convenience function for this. I don't have C document. Entrance. No, we could add it, I guess. Get entrance by key. Key. I'll get a nullable scene entity. If entrance, if it's an entrance, then we also check equals to key. If they are equal, we return the entity. Otherwise, we return null if we don't find it. Okay. So yeah, now we can actually just call that from scene documents. Scene documents. Oh yeah, no, because we need. Okay, we need the. or else null. So it might not exist. Oops, return null. So I guess we'll return nullable. So it's like the position, the entrance position might actually not exist. What does that mean? Well, that I guess it means that we can't have the cell because it's like missing the connection. So yeah, we need to add that as like missing entrance as an error. So it's like if this fails, if this is null, then we do return missing entrance. I guess we could do it here, I guess. And then we can do try. Alright, so once we have the entity, we can say entity position. We can just return entity position. Wait, yeah, that's integer vector, so we have to make it into a float. Okay, now let's see here. This needs to be relative to the map. Yes, this is still relative to the scene, so that's fine. Okay. Right, that should be good. Now, where are we? Down here. Well, we don't worry about rendering right now. What's this? Scene ID. Oh, this is seem to be processed. All right, let's just do an auto fix. There we go. So we get the formatting working here. Okay. So we're getting the scene document. We are loading the cell with the cell options here. We are going through all the entities, looking for the exits. Every exit we find that has a scene exit scene ID, we process that new exit and we create a relative cell structure here with the entrance key that we get from there. I guess the entrance key could also be like, yeah, it's gonna be empty if it's like a new exit entity. And the exit position is also, no, that should exist. Yeah, that exists, but this position is not relative to the map. It's relative to the cell. So we have to now do something here to get it relative to the actual map. Now, what variable could we use for that? How would we keep track of that? Let's check this example here. So let's say we start here, this is the origin, this is the map 00. We go here, this is the exit. We get this position by subtracting the entrance vector here. So now we're over here. But when we process this exit here, which is this vector, we now have to, like, it's gonna be, I mean, it's gonna be this plus this. That's this vector. But what about next one? So this one has the vector to that, and then so we have the previous cell, so we have this vector. No, we have this vector. And then we get, now the problem is this. How do we get this? Yeah, we get it by, so we do this plus minus, we end up here. Then we take this vector, so we take this plus this to get the next exit. Yeah, so we just take the plus the previous cell. Now if we're over here and we want to get this exit as a relative to, we want to get this vector here. So then we take the previous cell position plus this, but that will be this, so that doesn't work. Do we need to like have a separate variable for keeping track of wait, and we have this position. Now that's the previous cell, yes. And now we also have this position. So we kind of have, we have this in that case. And now we just need to, no, yeah, if we have this, so we just need to add that to get this. But if we're over here, and the previous cell is this, if we have one more, and now we're over here, we want to get this vector, right? But we only have this vector. This, I guess this plus the previous plus okay, so it's gonna be the previous plus like this plus the previous. So it's going to be this minus that. Yeah, that's that one. Next one is previous plus the entrance minus, no, plus the exit minus the entrance. Yeah. So you just take the previous position, add it in. Okay. I think so. I'm not sure. It's probably not that easy to follow what I'm thinking here for anyone, and not myself either. But I basically want to find the sort of absolute position of the next cell, and so where are we? Yeah, this part is let's go back. Okay, let's actually do this. Let's do this. Okay, so we start at one cell. Now this is the origin. This is 0, 0. Okay. Then we find we find an exit here. So here's an exit. Now we load the next cell, which is adjacent to this. Well, that has the connection to this exit here. So we have this position. This is the entity. That's this position here, the exit position. Yes, that's the exit position. Then, and that's fine when we start at 0, 0. But when we start here to get the next one, which we can take the entrance here relative to this. So we have the entrance position. We can go up to and we can find this vector here. Okay. So now we have the position of the next tile map or next scene. And then we also have the exit position here. So what we do want is we want this vector. And so we just take this plus this to get this. Okay, so we take the position of the scene and we add the exit position, and then we get the new exit position. Next we have another scene which is over here, and we have this vector and we have this. So we take the previous exit minus the entrance position. So now we get this vector. Okay. And then we add the next exit to get this vector. Okay, and then we keep going like that. Okay. Yeah. I think it's better to draw this diagram, because if you're gonna try and figure this out in the code and not have like the mental map of what's going on, at least when it comes to vectors and stuff, I find it's a lot easier to draw it out instead of like trying to debug a bunch of vectors in the code and see on the screen, like you get some random weird stuff happening on the screen and you don't really know what's happening. So what did we say? We said the previous minus the entrance would be so the exit position minus the entrance will be the tile map. The next exit will be the position of the tile map plus that. Okay. So this would be the position of the tile map. Do we have that? No, because we're processing it. And we need the next entrance to be able to... Right, so we need the next entrance to be able to know... No, but... no, we need this cell. We need this cells. Yeah, we just do this cell position, right? Okay, let's see how it works out here. And now this one is okay, let's just do this. Sometimes it's a bigger hurdle than what it actually is. I don't know. Okay. Are we done here? So we're going through all the exits. We're calling those recursively again for each exit with this. That should be good. And then, oh yeah, so to calculate the position of the cell, we take the exit position of the last, that is relative to the map, minus that. Yeah, that should work. Okay. Well, I mean, it should be how I thought it should be anyway. So we'll delete this. So now we have this fully realized. The only thing left is rendering the map. So if the map looks good, then we can go ahead and build a UI for it as well. So well, we need to build a window and stuff to actually see how it looks. But yeah, now we need to render the map, and this is basically pretty simple. We need to do for each cell in the list, which we already have. We will load the tile map and use draw tile map to render to the render texture. Oh yeah, also, oh yeah, we also need to actually, number one is calculate the size of the map and initialize the render texture. Yeah, that should be number one. And then we load the tile map in here. We draw the tile map. Yeah, and that's basically it. We also need to check if we have this from before, then we do unload. Render texture. Okay. And now we calculate the size, so let's just do that. Size, calculate size, map size. We need to implement that. And then we do self render texture is equal to load render texture with size 0. Oops. Size 1. Alright, and then we loop through our cells. Let's do values. I was gonna think it's an ID here, which is not. I don't know. There's a bug in LSP that thinks that the values of the hash map is the keys. I don't know what's happening there, but it's not, and the compiler doesn't think so. So anyway, the cell. Let's see what we're doing with cell. We're loading the time up document. So let's. We have. Let's see. The cell should have it. Oh, it might not actually have a time map. Yeah, I mean, I guess if it doesn't have a time map document, if it doesn't have time map ID, then we just skip this one. But if it does have one, then we do this. All right, and then we need the context. And right, so once we have that, oh yeah, this is also this could be an error because we're using try there. Use draw time up to render to the render texture. Yes. So we basically just draw the time map. We can use a camera to sort of offset where it will be drawn, I guess. Unless I don't remember if draw time map actually have position. Yeah, so we have position, so we don't need to do that. So position is gonna be cell.position, except it needs to be converted again. So from float. I'm sure maybe we should have like, no, let's keep it float, I guess. And any kind of like decimal errors or something, it's just gonna get truncated. It's just, it doesn't really matter that much. Yeah, so draw time map, the scale, I guess. We'll just put one to not confuse things right now. Override focus is true. So we don't do any fancy effects depending on like the settings of the time map. Okay. And yeah, I guess that's it. Try, no, or else, yeah. So if this is null, then we also continue. We don't have a time map document to draw. Okay. Are we calling this function? Yes. I guess it could be called just build or generate something. Okay. No more errors in this file, so that's a good start. Now we'll build a UI for this to live in. We also need to put this somewhere. I think we'll just put it in the context for now. And we also need to add it to the lib scene map. Okay, let's add it somewhere. I'll just add it at the end here. Wait, it didn't have empty, right? Just in it. Yeah. All right. Now what? So I think what we'll do at set project. Oh yeah. Project. So I think here, oh yeah, load project, we'll probably put it in here. After we loaded this stuff, we do scene map. Maybe that should be part of the project instead. Oh well, whatever. Generate. Yeah, this could be an error, so we'll catch this and we'll say show, actually load project. Yeah, Let's just do a try, I guess. Okay. Alright, so now we should be generating that. Let's just start it up and see if it runs. There's an error. Oh. Expected loads of funnel. Oh yeah. This should be the starting point. So this starting cell. Error union is ignored. Let's do try and try. Field or member function and grid size. Oh? What? Oh no. I crashed it again. So it should be there. I mean, this is oh, because it's null. It might be null. Is that why? Right. Actually, you know what? I don't like this to be. Wait, this is how to do it. This is how to do it. Let's do it like this instead, so we don't crash the LSP. Does it crash now? Oh my god, it crashes. But I set the type. Okay, there's something weird going on there. Maybe I should report that. Okay. So I'll not check the type of that. But it is nullable. So how would this work? Let's see. If it's null, I guess the size would be nothing. Like if we don't find the document, then it's not gonna get. So let's do time app document. If we get it, then we get it there. So let's do time app document like this. And then otherwise we will do. Actually, we could keep that. Otherwise, this is just gonna be 0, 0, I guess. What's this now? Try. Oh yeah. I guess we can just remove this. Okay, missing size. Right. So what would it? So this could be the same thing then. So we can just copy this. Size. Render map context. All right. No field memory function. You calculate map size. Oh yeah, we didn't do this one. So let's implement that. Calculate map size. Do we need anything? I think we need context. No, we don't need context. This will return a vector. Wait, does it? No, this should be a integer. Yeah, so let's just do this. So calculate the map size. This is going to be pretty interesting as well. I mean, I think what we need to do is we want to find. Let's say we have a cell here and a cell over here like this, cell like this, and a cell over like this. So basically, I think we need to find 4 different points that maximizes each of the dimensions and also the like positive and negative. So basically, this and this, and well, we don't have slopes like this, so this looks like a bit weird, but oops. Oh. Okay. And then the point maybe down here, I guess. Oh, come on. And then one of these. So we want to find basically all like max, min and max. So min x, min y, max x, and max y. So basically the min and max of each dimension basically we want to find. So we need to go through like basically all of the points on each like rectangle for all the time maps. And we want to keep track of min, which is min x, min y, max x, max y. And once we have that, then we have the whole. Then we can draw a rectangle around the whole thing, like this. Because this point will be min x, min y. And then this point is going to be max x, max y. Okay, so now here we find max x, here we find max y, here we find min y, and here we find min x. So in this example is an extreme example of all the points are in different places, or yeah. So yeah, that's what we need to do. So let's go back here. Okay, so we basically keep track of min x, and to keep this sort of so what would the starting be? We could set it to 0, but a more robust way would be to set it to something that is it can't be larger than, because then you can be sure that you're actually like, if you, let's say you set it to 0, then what if all the points are greater than 0? Well, then 0 is like, is not even a point that, or I mean it's not even a value here that you need to, that's the wrong value, because all the points are like positive. So what we need to do is we need to have, what is it? This is I32. So we need to have like max, no, what is it? Math infinite I32. So returns the, oh, this is floating point. How do we get like the maximum value? Max int. So returns the maximum value of integer type int. So we have the maximum value. That means you can't have anything that is less than this, or that is larger than this, I mean. So so you reach something that is less than this, which is like any point basically, then this becomes the min-max. So at the start it's gonna be sort of unset basically. You could also use null or an optional, but I think this is more like, yeah, if you do it like this, you don't have to deal with the optional stuff. So same thing for this, and then actually we don't need to set these now. Max is, this is the same thing, but now we do min int instead. Returns the minimum value of integer type t. Max y. There we go. So now we have those. Now the idea is that we just loop through all of the cells and we calculate the 4 corners of each rectangle, and we try to find out, we just check if any of those points are less than the min or greater than the max, and then we update those values to match that. And at the end we will end up with the ones that are at the extremes. So we'll go through the map cells here. Oh. And now we need all the corners. So we have the, wait, what's this? Oh, this is so we have position, because the LSP doesn't know what's happening here. But this is going to be the min, and then we need the max, which is going to be min plus size. Okay. Now these are floating point vectors, so we'll make them into vector. Let's just use vector. Yes. Instead, we have a built-in type for this here. Oops. It's just an alias for an integer vector, but it's easier to use. Just put it there, since we have it in other places in the code here. So we have the min and the max now, except we don't, because we need to do int from float first. Right. And actually, you know what? Let's do this. Let's do min is a vector. Let's do this instead. Because we're working with vectors, then you can utilize the fact that what is it? SIG has like built-in support of vector math. So now this is a vector, and splat basically just takes a scalar value and puts it in every element in the vector. So now we have min, we have max, and this is min and max, but this is like the cell min, cell max, and this is cell min. Okay. So now we have cell min, cell max. Now we can say now we can do this. So now we can say that the new min is going to be at min of the min or cell min. Min equals min, min, cell min. Yeah. So the minimum position here is going to be, or yeah, min of this. Now the way this works is, I believe it's component wise or dimension wise. Takes 2 or more arguments to turn a smaller value included the minimum. This built-in accepts floats, integers and vectors. In the case of vectors, this operation is performed element-wise. So you're gonna get the minimum x or y. Like it's not like it's keeping the entire position. So you're gonna find the minimum here like this. And then we do max, we do the same thing basically. We take the max and then cell max. So whatever is largest is gonna pick that. So now at the end we will end up with the minimum and the maximum. And to get the size now of the entire thing, what we do is we just say max minus min. Now should we also return the offset of this rectangle? Like, should we just return min as well? Because like should we just return min and max maybe? Because we probably want to get the offset, because when we draw this, what would the position be? Well, the position could be like negative here. So we don't want that. We want it to offset by the minimum. So we actually, what we want is, I can return a tuple here. So let's do two vectors where the first one is the min and the next one is the size. So min is the position and then this is the size. Okay, so calculate map size, so position like min and size. So now we can grab them both out like this because it's a tuple, so you can grab min and size out like that. Then we have those. Now this also works, yeah. Now what else do we want to do? Let's fix these things. Let's see, incompatible types, I32. Oh, yeah. Let's just do this. Make it into cell size and then cell max. No. We'll make it, yeah, it's just added, so yeah, so we'll do cell max plus equals cell min. Right. That's easier, and like otherwise you would have to it's just these coercions that are a pain in the ass sometimes. Okay, so then you have min, what's this, expected? Oh, so this could be an error, so what should happen then? I guess we'll just try this. There we go. Alright, so now what about min? So here, let's say the min is like 0, 0, then we don't really, nothing happens. What if it's negative? Like, let's say this position is negative, this is actually the min, let's say, so that position, let's say that's equal to min. How would we then we want to set that actually to be 0 in this case? So we could take a negative plus itself, right, to get 0, right? So it should be offsetted by min, or should it be negative min? I think it should be negative min. Yeah. Negative min. Yeah. Oh, no, this one. Let's do cell position is a vector. It's int from float. Cell dot position. So I wanted to have them as floating point because to get the calculations correct. But then now, because the entities positions are floating, I think. Actually, I'm not sure about that. Maybe they aren't. Maybe I just made a whole bunch of extra work for myself when it's not actually needed. Wait, what's happening? Oh yeah, this is cell position. Cell position. There we go. There we go. All right. Now what? We don't have anything else happening in here. What's this now? 3 August. Oh yeah, this needs to be right here. Expected. Oh, this is this under. There we go. Okay. So we're calculating the minimum position and the size. We're now passing the size through here. So we're initializing that we're render texture with the size. So that's good. And then we're drawing the time map onto this render texture. Except we're not. What we need to do is we need to use, because now draw tile will draw onto whatever's the target in the sort of Rayleigh context or whatever, which is the screen. So what we actually want to do is we want to do begin texture mode. So there, because now this is actually now everything that is called in a draw function now will draw onto this render texture instead of the screen. And then we also do defer and texture mode. All right. There we go. Okay. Let's do like if this goes wrong, I actually want to catch. Well, actually. Let's set it. Actually, let's set it to null first. I guess if it exists, we unload it and set it to null. There we go. Because if something goes wrong here, we still have like some sort of. We could still have like a value to it, and so that's why I don't want it. Okay. So anyway, now. Yeah, let's just roll this home here. So where did we have the layout for this stuff? Actually, yeah, I was trying, because we are calling this initialize stuff. So I want to actually run this and see if anything goes wrong first. Okay, missing entrance. Interesting. Could not load project. That's also interesting. That it says it like that. That's not actually maybe accurate. But it is in the project. We do have load. Wait. No, it's restore session, I think. No, it's context project. That's right. Here, yeah, generate. So missing entrance. I would like to know more. So let's go in here and let's actually find that. I wonder, anytime we do this, let's see, where do we have missing entrance? Here. Okay, this is the only place. So if we have a missing entrance, I'm gonna also log this out. Could not find entrance. Well, it's not necessarily an error, you know. Actually, if we don't find the entrance, sometimes we just don't care. It's like the position of what? Position of the cell. And we can't get it if we don't have an entrance position. So if we don't have an entrance position, then we actually want to skip this cell. We don't. So let's not do that. Let's go to where we load the cell. So it's like here. If we cannot load the cell, basically what I want to do is I want to catch this error and just return I think, and we want to log maybe warning, could not load cell C to be processed, or that's the ID. Okay, we'll do that. See what we get. Okay, so we don't get the error anymore. Let's go into the logs. Oh, do we have leaks? Oh, we have, oh yeah. We're not calling the initialize on the scene map. Okay, let's see if we get it now. Oh. Wait, what? Oh. Okay, now we don't get leak here. Okay, what did I want to test? Oh yeah, so do we get error messages here now? Could not load cell, missing entrance. It's just one. So maybe we have a missing entrance somewhere. I guess we'll find out once we see the actual map, because we'll see which one is missing. It might be, I don't know. Okay, so now we are ready to build the window that's gonna show the scene map. Where would we put this? I guess we could put it in its own thing. Layout, scene map. Right. Scene map UI. That's a function. All right, so we need a context. And let's start with a window. We need that. So it's going to be the scene map. And at the end. Alright, so let's start there. Let's do also window size is going to be condition is first, and we'll just set this because otherwise it's going to be like a 1x1 size window or something like that. So let's just set it to something larger, and let's set the position. I guess like 100 or something. There we go. So usually it's standard for like a larger window or something like that. All right, then we do begin scene map. Right, so this should be pretty straightforward actually. We should just be able to get the render texture here. Let's do if. So that's the render texture. And then we just do, actually we need view orangui draw yeah, it's just gonna be no a render texture, yeah. So just a render texture. Now this is just gonna be pointer cast. Let's also do pointer there. Yeah, let's start there and see where that takes us. What we also need is we need a flag for this to be open or closed. So is scene map window open, set it to false, and then here we have a big old if context is open, and we could even actually have p open there. There we go. So that way when you click on X on the window, it's gonna close. It's gonna also set the bool to false, which will so close the window basically. All right. Yeah, so now we should actually see the render texture there. And what else do we want to do? We want to call this function from somewhere, and we want to be able to actually open the map somehow. So let's go to our layout function. This is the main layout function, which is probably where we want to have this, because the window is not going to be part of a specific editor. It's going to be like project wise. So this would be in here, and if we have a project, we have the project menu, we have the tabs, we have the editor, and we have the assets manager, and let's just put the scene map in here. There we go. Now we're actually calling it. Okay, now we need a way to actually like open it up. So I think I do want to have a shortcut for it, but first I'm gonna add it to the project menu. Oops. Project. So there's the options menu. Let's just add, I think, yeah, I'm just gonna add a, wait, no, that's the window here. So we're just gonna add a selectable. Actually, it should be same line. And this would be scene map. So this will context is scene map window open. We'll put it true. Alright. Now let's try it. We should see it getting open now. What's happening here? Okay, the selectables are acting a little bit weird. Flags. I'm not sure why it's a selectable. It's like, why not? Let's just do a button here instead. There we go. It looks a bit weird, like when you have menus and buttons in the same time. But I'm probably gonna add them as like a view or something. I don't know. Okay, here we go. Here's the scene. And you can see it sort of works. I think what I want to do is maybe zooming to where you can see the entire thing, maybe. Yeah, but I want to add the camera control so that you can move this or move around in this thing. Also, maybe the transparency should be, I don't know, more in this window. Yeah, we need camera controls. So let's add a camera to this. Scene map camera. And I'm just gonna put these like 0, 0 and everything for now. Rotation 0. Wait, why is that not? Oh. There we go. And yeah, so now let's see, in here we can do begin. We need really begin camera or something. Begin 2D, mode 2D. Yeah. Context scene map camera and end mode 2D. Okay, so now it's hooked onto this camera here, so you can use this camera to sort of move the view around, let's say. If we hook up controls to it, that is. So that's what I want to do now. And I did this somewhere else. I forgot where. Oh yeah, the scene or the entity reference thing. This should be here. Entity reference somewhere. Here's the window. And we have somewhere we have the camera somewhere. Where is that? Wait, where's the camera? Camera controls. There it is. Yeah. Oh, okay. Yeah, I guess it's just camera controls. But then we also want this. Is item hovered? To make sure that we're over the map in the window. And we have to do it down here because it's gonna be like, is item hovered, but which item? Well, it's the one that we just did. The latest one that we did, so this one. Okay, and then we need to import users and camera controls on the camera. Camera is context scene map camera. Okay, and let's see if we can use it now. No, really to. Oh right, these are. We have to say like this. We might have to fix the offset. I'm not sure exactly. We'll see. It depends on how we want it to work, but. Let's open the map. Okay, so that doesn't work. Why is that? Should we disable CMap? We should disable scrolling. Yeah, I'm not sure why it doesn't work, because it did work for the other place. Let's go back, because if we go over here, is item hovered? It's the same thing. We're rendering a render texture. We're checking now if the item is hovered. We enable the camera controls. Oh, hello, baby Yoda. How's it going? Target. No, but here's that is not correct. Yeah, I'm good. I'm implementing a scene map here. Little quick and dirty thing that turned out to be. I mean, yeah, I've been sitting a couple of hours trying to implement it, but now the camera controls doesn't work. So I have this working sort of. It's sort of the transparency of the window. Maybe I should fix that before I can. What would that be like? Background? No background. False. Transparent. Set window background. Alpha. What is that? 1? No, 0 or 1. Okay. Yeah, but now you don't see the the black tiles. Okay. Anyway, so I'll try. So I have these scene files, and they are sort of connected with entrances and exits, and I'm basically looping through all of the entity or all of the scenes. And I'm building up this map so that you can more easily go to whatever scene you want, and you get like an overview of the map as well. But it's not something that's gonna be like in the game or anything. It's just for the editor to easily see and go to other like places. And I had this idea that, well, I have the entrance and exit, so I could just connect them at their entrance and exit positions. Because they are basically, I always try to keep them the same size and everything, so it should, in theory, work. We're not seeing the whole picture yet here, but I'm gonna try and fix the camera controls because I cannot scroll this now. I'm not sure why, because it worked for the other view that I had. Yeah. It would be cool to see when it when it works, and we can see it would be cool to see the whole map at once and zoom and stuff. But I'm not sure why it doesn't work. The only thing that's different is like the offset is usually set to the center of the width and height, but it feels like something should happen. Yeah, let's So what we could do maybe is, well, what we could do, we could just set the offset to be render texture with texture width and then divide it by 2. I think that's how I usually did it before. I'm not sure if, like, why would it not work? No, of course, nothing's changed. Using matrices for this is usually better. Yeah, yeah. Probably. I'm not that versed in that actually, but I mean, I know that you can have a transform matrix and just apply it to the points, but this is just a case of we have this. I have rendered the texture in img, and then I check if we are hovering over the thing. So maybe that's not, then maybe that's what's not happening. Let's just remove this. Because I know that the code, like this is using the same code here, but it's like in a different context. So there's something weird going on here. Why? And I know that it should work in a window as well, because if we go, let's say we go to this scene here, and we do this button thing. This is using the same thing. This is now in a window. I'm controlling the camera, so it should, you know, it should work, but it doesn't for some reason. I'm not sure why. Maybe because we're beginning mode here. And we're rendering the texture. Let's just check everything is what is different here. So here's the same thing. We're beginning and there it's drawing the entities. Oh yeah, but that's including the time map. That's right. Oh yeah, that's onto the texture. Oh wait, no. Oh wait, we're actually, okay, I see. So we can't use the 2D mode thing with RLImg render texture, I guess. I think that's the issue here. I think that's the issue. Like we have to like what that's. Okay, let's do this. I mean, we have to render like a render texture every frame here. So we'll do render texture, or this is like the window render texture. And then there's probably a way better way to do it, but I feel like shit right now. Slept yesterday, didn't publish my website yet, and I need to have it published. Oh shit. Do it. There's no other way. Yeah, so we need to create a render texture. So we need to do load render texture. The width and height should be window size. No, it's the get window size. So there's the window size, although it's the wrong type. So let's do window size. Actually, is it window content region? No. No, let's do window size. And the height is window size 1. Okay, so there's our thing there. Let's just catch unreachable here, whatever. And then we have our render texture, and we will draw. Now we draw render text. Wait, render texture. Draw texture. Draw. What do we do here? What are we doing? Oh yeah, you can draw a texture. I'll just draw the texture like this. This would be window render texture dot texture 00 white tint. Okay, so now we should have drawn the texture using mode 2D, but we also wait, no, it's not this render texture. And then we also want to do a texture mode because we want to draw onto the window render texture. Okay, so we have both. Now we do the same thing as we do in the other place. And lastly, we want to draw now the window render texture. And once we've done that, oh no, now comes the problem again. We have to store this between the frames. Okay. Okay, let's just do the easy way here for now. I'll just put this here, scene map render texture. Scene map window render texture, let's call it. Render texture, yeah, whatever. Just undefined, sure. And then this is not that, this is gonna be context, scene map, window render texture. Okay. And oops. There we go. What's this? Expected float type found. What? Oh. That's okay. Let's just do window width, height. I wonder if you can do this. Oh yeah, but then you can. Oh no. Wait. No, that doesn't work. Okay, let's just do in front of it here. There we go. Okay, let's see if it works now. No. Okay, I felt a little crash somewhere. No, I didn't. Maybe not. Oh. Okay, there's definitely. Wait. No. Yeah, we don't wanna like do this every. Yeah, because we're never unloading it. Yeah, let's just do this like one time. Here, I guess, like onload, or I don't know. Where do we have it? Like we have a render. There's another render texture somewhere, I think. Yeah, that's the scene. But that's part of the scene stuff. I mean, we could just do it here. We could just say scene window and texture is equal to load render texture. I'll just hard code in this for now. Catch original. And no minus. I guess we technically could have like an if the size is different from the texture, then we sort of adapt. So if window size has changed, reload render texture to match window size. Yeah. All right. Okay. Well, okay, it looks even weirder now. So sure, let's do like clear background, I guess. Let's do like gray. Is there gray? No. We'll see maybe a little bit more what's going on here. Okay, there. Okay, that makes sense. This is our thing here, but we don't really see anything going on. So we're drawing onto this with the texture mode. We're drawing this texture onto it, which should have the actual texture on it. We end those things using this camera as well. Then we put a render texture onto the imgui sort of drawing command stack thing. That should render this texture. We have this thing. Yeah. Oops. I'll just do this for now. Okay, there we go. Maybe it was the offset that was weird. Oh, and you see is it upside down? Oh yeah. So you can see it sort of works here. Hey, that's kind of cool. It's a little bit weird. The offset sometimes doesn't really work. This was basically sort of expected, really, like having overlaps and weird quirks like this. Although this looks really weird here. Like this connects. Okay, something is probably very wrong with like matching like algorithm here. It's a basic structure, but yeah, it looks very weird. So the yeah, you can see it's upside down. Well, maybe you don't see it, but I can see that it's upside down, and that's because it's like a render texture. And it's I read about this because I had this problem before, and apparently this is how it works. It's just upside down because it's a render texture. And so if we go over here, we should have something happening here. This is render texture. This texture is that. Let's see, what am I missing here? I think I somewhere render scene. Somewhere we should be handling that. Yeah, this is a little bit of mess here, but that's why I'm not finding stuff easily here. Don't actually remember. This is the window, right? So we should have a combo buttons or combo list somewhere that where you select the scene. Here we go. And then when you select the scene, we do this. Then it's just like that. Okay, okay, okay. Well, then what? We should have like, yeah, here's the render scene. But where do we actually render? No, it's here. We're just drawing it right off, straight off here. And then we're rendering it. But why? But it was upside down at one point. I remember that. So how did we fix that? I don't remember. It's not like this is like negative somewhere. Where did we fix that? I don't remember. I'm confused. I am very confused. Because it doesn't look like we're handling that here. Yeah, the thumbnails. The thumbnails was also upside down. Why is that not upside down? Okay, that's strange. The thumbnails was definitely upside down. Here we go, flip. But why doesn't... That's very strange. Maybe it's because we're drawing the texture beneath. Right, maybe that's why. Ah, maybe that's why. We're doing this instead of like... Yeah, because there's no draw render texture. Just draw texture. Okay, so after all that is done, we do flip, vertical. Wait. Oh, we have to do an image as well. Oh my god. Okay, so we do an image, we flip it. But then we have to save the image. Oh my god. I wonder if there's like a... Well, I could do image, render texture, oh shit. That's fine. Everything is fine. Okay. So why do we need to go through all of these hoops to do this? So we're rendering, so we have the whole original sort of texture, right? So it's like, it's because Oral Imgui does not care about the camera. I think that's the problem. Like if this, I guess you have to maybe do like begin and end on this, maybe. No, we already have that. Yeah, we're already in that context. Now, what didn't this work before? Like, just doing this, except we don't do this. This did not work, right? It just renders it without caring about the camera. That's the issue here. Yeah, it doesn't care about the camera at all. Okay. And there's no like camera in here. There's no like things like that. What about IO? I'm pretty sure, yeah, there's IO, there's like, I don't know, there's things in here that doesn't show up. It just shows a bunch of functions. Gizmo? What's this? Plot TE? What is TE? Test. Oh, maybe it's like test engine. Okay. Standard search, draw, index, editioners. Okay. No, it wouldn't be in there. It's like if you go now, you can, and this is C, so. I mean, maybe if we use this version, I'm not sure if that does any difference. It should be the same sort of code that's running, right? Let's do a bit cost. No. Okay. You also have like scissor mode and stuff like that. Well, it's no, it's RL begin scissor mode. scissor mode. What is this? Define screen area for. Oh, okay. Yeah. Maybe we can take. Maybe. Yeah, it's like I can see how we could do it. It's just it just feels bad that we have to go through all of this effort to do. I was trying to find a better way to do it, but do it. Yeah, the issue is over here. It's like, why can't I draw a render texture? Why can't I draw? Is it because it's... Wait, but couldn't I flip it? I could flip the source, maybe. This is kind of strange because it's kind of funny because I have an inkling that this function actually flips it as well. So it's like it's getting flipped once we render it. This texture is like flipped. So when we render this now, it's flipped. But couldn't we do this? Draw texture. Actually, yeah, couldn't we do the, like, where's the scale? Can I just have a scale X? Yeah, so X, and then no, but the scale needs to be two-dimensional. Yeah, what if we do like PRO? But now I need like a source rectangle and stuff. Well, I guess so x0, y0. This is source. And these are, I think they are floats. This is not a float. Yeah. Okay, that's the source rectangle. And then destination. I'm just gonna do the same thing. Source. Let's try this. I don't know. Oh shit. No, but it doesn't work. Okay. Yep. Wait, couldn't we do this then? Okay, let's forget about these. Go back to this. 0, 0. Yeah, it's just position X, Y, and things, yeah. So now it should be upside down, right? Okay, yeah. Upside down. But what we do is we, instead of doing render texture here, which probably turns it upside down anyways, let's do image. Texture. That needs to be like cast light. Or oh, okay. Well, there you go. Except like up and down is like reversed. Okay. So wait, how do we fix this now? Okay, but it is drawn. Now, one thing that I'm thinking of here is like, okay, will this really work? Because I don't think you're supposed to be able to just access this and render it, because from what I understand, it depends a little bit on the hardware, and what if there's like a difference? So now all of a sudden it doesn't work for certain kinds of hardware, which is, but okay. But it's not an optimal solution, is basically what I'm saying here. Okay, so it does sort of work. It's just that the controls are inverted now. So yeah. And I don't want to change this too much. I mean, we basically want to flip the Y. Maybe we can put in options here. Or actually, what we could do is we could, before we do this, we flip the Y. Also watch me like not add comments here and be very bewildered by what is happening. When I get back here in the future. Okay, we're flipping it back and forth. I mean, I guess you could also do this. Make it a little bit more terse. There we go. All right. Okay, let's bring back the offset, because feels like that should work fine. And also doesn't feel like it takes a long time to do it either. Okay, now it can't find it anywhere. Is it supposed to be like negative? I don't know. Okay. Huh. No, it's just set to half of the size. I just want to get this sort of working before leaving here. Well, it does sort of work, you know. We have this map now rendered. It looks a little bit wonky and funky. Oh, and now it doesn't. Oh yeah, because of the offset here. I was just trying to fix the offset so that when you zoom here, you see it like zooms from this point. This is like the origin over here. I want the origin to be like the center of the map. But as you can see, it sort of works. There's some. I think there has to be something wrong with the positioning here, because here's, let's say, here's the village area. This is to the right of the village area, so it does match up a little bit, but not entirely. This is the position of the exit here, and this is the position of the entrance. They should be at the same point. Same here, but it does sort of look correct, you know. And then this is the same over here. So there's something wrong going on with the... It's kind of interesting. You can see that this actually ended up above here, which is sort of almost... This is... Let's see how it matches against the map that I made, which is here. Okay, I'll disable a bunch of stuff here, and let's put this okay. I'll just take a screenshot. So you can see how do I want to scale it up. And let's make this a new layer. So yeah, you can see this is actually more the forest area, so it's this area only. It's like this. It's almost, you know, And granted, some of these areas I've not actually done fully here, but yeah, it sort of matches up. So it's kind of cool. So it's basically like automatically like generated here. This should correspond to this. Oops. This part should correspond to this part. This, I guess, all of this. I added a little bit of scene here. Should correspond to this, which it does. This corresponds down here. We have this part, which I matched up here. We have, but then there's like a gap here. So this part, no, actually, yeah, this should be down here. But then this is almost correct. It's not, you know. Yeah, and here is like a little bit of mess. So I'm not sure. Maybe it starts with. Maybe it now depends on what it starts with, and it's like. That's how it. Like maybe it starts with the first one, which may be this one or this one. I'm not sure, really. But it does sort of work. I just have to figure out why the positions are wrong. They should match up. Okay. Next would probably be to like debug a little bit, like paint out maybe where the entrance and exits were matched in all this, and so maybe you can see like, okay, what the issues are. But yeah, I think that's gonna be it for this sort of iteration of this thing here. So yeah, this would be it's more, it's, I don't know, it's kind of a fun thing to do. It's gonna be a quick way. I'm trying to improve a little bit on the quality of life. I added a bunch of other like small improvements to the editor as well, like when you create a new asset, and I've also restructured the code a little bit off stream and stuff. But yeah, that's gonna be all that I have time for today. So yeah, I'll see you next time.